Just want you to first of all get to expand what's there on the denominator, then get to divide. So we'll start first of all by expanding what we have. So what we have is we have I excuse me. So basically we understand that this is the same as I minus 1, then I minus, you get to repeat the brackets twice. So what happens if you multiply I with I is what? We basically understand it's I squared, right? Then I by the negative 1 is negative I. Negative 1 by the I is negative I. Negative 1 by negative 1 is 1 squared, which is just 1. I hope I'm not too fast. Last time we said that I squared is equal to what? What do you say? It's equal to a negative 1. Do we agree? This is the part that we say is an imaginary part of a complex number. Okay. So meaning that at that point where we do have a I squared, we can plug in the negative 1. So there will be a negative 1 there. So I have a negative 1. Then this part, you're adding. Basically what we get to have is we'll have what? A minus 2i plus a 1 there. So from that point, negative 1 plus a 1 is what? It's a 0, right? So you just remain with a negative 2i. Do we all agree? Have we followed what I've done there? Excuse me. So from that point, what we have is we have 2 plus 3i over what? Negative 2i. So at that point, basically what we're from doing is we're from revising the concept of how it gets to multiply these complex numbers. So now the next step is going to tell us or guide us on what you get to do when you're dividing. So we said when you're dividing complex numbers, you get to multiply by the conjugate of the denominator, and we said a complex number in the form of a plus ib, its conjugate. Of course, I said whenever you get to say something with a bar on top, it's a conjugate of that complex number. And you just get to change the sign of the imaginary part, which is just going to be a minus ib, meaning that I've just changed the form for imaginary part. So on the other hand, let's say if it was negative, it would have, its conjugate would have been what? A positive. But the sign of a doesn't change, only for the imaginary parts. So in this case, I don't know if it's fortunate true or unfortunate true, we just have the imaginary part, so we just want to change the sign of it. So we have 2i, we multiply both the numerator and the denominator with the 2i. So what do we have on the numerator? So 2 multiplied by the 2i is what? It's basically 4i. 3i by 2i is basically 6. So I is going to be squared because there are 2 that we are multiplying there. Then on the denominator, okay, now what I say? What's the question? Wait. What point did I make? I said we are multiplying by what? Is it the complex number itself or its conjugate? Okay, so you don't get the complex number on the bottom, but you get its conjugate, meaning that you change the sign of the imaginary part. Okay, so what happens if you multiply this with that? What do we get to have there? Quiet, so yeah, so you shouldn't be keeping quiet to expect somebody else to respond on your behalf. So what do we have on top? So where there's I squared, what are we going to put? We said I squared is equal to what? Ruth, what did you say? Okay, I'll put a negative 1. Then the denominator part we have negative 4i squared, so put a negative 1 again. This is basically going to be equal to 4i minus 6 over what? Over a 4. Do we agree? Do we agree? Pardon?
Yes.
So 4i divided by 4 is what? It's I, right? The negative 6 divided by 4 is what? I don't want decimals. What's the highest common factor? Are we okay there?
Yes.
The question that I gave you was 1. So we're trying to find the absolute value, okay, of that. And I told you that when you have a complex number in the form of a plus ib, what did I say about its absolute value? It's equal to what? If you remembered what I said last time, do we agree?
Yes.
Okay, so now if you look at what we have in that case, do you think it's going to be easier for you to deal with what I'm saying? Do you know your A in that case? Do you know your B? You don't know. How do you get to know it then? So it requires you to express what is in the brackets in terms of what? A plus IB, which is like what we're from doing in the previous question. So first of all, what we have is an addition. We'll have to add. Then thereafter, we'll have to divide. Obviously, because if you get to add something, obviously you're going to come up with a common denominator. So what is the common denominator there? It's going to be the product of these, right? So we have 2i being multiplied with 1 minus 2i as our common denominator. So we understand that if you divide by the 2i there, what you're going to remain with is the other part being multiplied with the numerator, which is just going to be 1 minus 2i. Then even as you get to multiply this part, you remain with the other part, which is basically just going to be what? A plus 2i. At that point, you'd agree with me that what would be the solution there? One over what? Two I then minus 4i squared, right? Then at that point, what do we have? Okay, so you are moving too fast, sir. So we have 1 over what? So we said I squared is equivalent to what? Negative 1. So we'll have 2i minus 4. So wherever is a negative, wherever is I squared, we'll put a negative 1. Which is basically going to be what? 1 over what? 2i plus 4. Are we okay there?
Yes, we are. Now, sir, may I ask a question? On that other one, the one I'm doing, the last part, the one, the 4i minus 6 over 4. What did you do? Because me, I was thinking of dividing two over three numbers.
Yeah, taking us back to the previous question. That's what it is.
I just want the last part. I didn't get it. 4i minus 6 over 4.
4i minus 6.
6
So,
over 4.
so what are you trying to say? What would you have done?
Yes, your last solution
What would you have done yourself?
I was thinking maybe you divide like 2 into all these three numbers, like 2 into 4, 2 into
So
4.
what are you going to have if you
So
divide? So you have 2i.
2I minus 3 over 2.
So you can end there.
Mm-hmm.
Okay.
Oh, okay, you divide them this way then.
No, basically, I want it to be in this form, madam. I just want it to be. There is no denominator there. There,
Okay. Okay. Okay, alright. Making sense now. Great.
okay, so what are we saying now? So what can we do from that stage? We have 1 over minus 2i plus 4. Are we able to find the absolute value from that point? Or we still have to simplify it? By the way, if you have challenges with, are you able to see clearly what I'm writing?
Yes. Yes.
Okay. So what do you get to do at this point? I've even shown you what to do. Eunice, what are we going to do?
We are going to write 2I minus 4. We are going to multiply
I
with
want you to use the weights that I've taught you. We are going to write. Of course, we are supposed to write, but then what are we doing?
we are going to multiply
What,
and conjugate
with what? Because we have two things there. We have the numerator and the denominator. So,
the denominator.
okay. So what's the conjugate?
2I minus 4.
Okay. So we just write it like that. We just multiply it with the denominator. That's all.
Even on the numerator.
We know the numerator. Wow. Okay, so Eunice. Okay, are we all in agreement with Eunice? What did I say about the conjugates? I said you change the sign of what?
Yes.
Okay, so I made the point. You look at the imaginary. So Eunice, what you said is at least you have an idea. You have a concept with you. Okay, but take note of the imaginary part. So we'll maintain the sign of 4 and change the sign of 2i. Are we together?
Yes.
So after multiplying the numerator, what do we have? So the moment you're multiplying with 1, don't even waste time because everything is going to be maintained. So basically, we just have 4 minus 2i divided by, on the denominator part, what do we have there? So we have 2i basically being multiplied with what? 2i by negative 2i, which is basically what?
Negative 5.
Then again, 2i by 4. Then again, 2i by negative 2i. Oh, what? So we are now on the next part, 4. So 4 multiplied by negative 2i is basically going to be, so it's going, so like this is why I said last time that we don't get to indicate the middle part because it's basically going to subtract and cancel out. So you just get to multiply the like parts. So 2i by negative 2i is negative 4i squared. Then 4 by 4 is 16, right? We can move. So we have 4 minus 2i. Then on the denominator minus 4i squared. So we said I squared is a negative. So basically we have negative 4, negative 1 plus 16. So that is going to become a positive, right? To become the summation of 4 plus 16, which should just be a 20. At that point, we have 4 over 20. Negative 2I over 20, which is what? 4 over 20 is what? It's 1 over what? Then that is I over what? So at least we have it in a better form where we are able to identify our A and our B. So us finding the absolute value of such an expression would be easier to deal with. Are we together? So we said it's basically, what did you say about the absolute value? It's A squared plus B squared. So our A in this case is what? 1 over 5. Our B is what? Excuse me. That's 1 over 10 squared, of course. 1 over 5 squared is what? 1 over 25 plus, that is 1 over 100, right? So what's a common denominator? I want to show you how to simplify. I'm sure calculators are not allowed, are they? Gideon, are you allowed to use calculators in second semester? Okay, so you have 25 and 100 as a common denominator, yeah? So if you divide by 25 into 100, how many times? 4 times, right? So 4 plus the 100 is just once. Is that okay? So we have 5 over what? 100. This is the case where I get to simplify it. So root of 5 over 10. I think that can be our solution. Do you have questions? We've all followed?
Yes, sir.
Followed. So how was I even adding? So 1 over 25 into that is a 4 plus 1, and that is 5 over just the 100. Okay, then we have root of 5 over 100. Okay, basically can you simplify it more than what I've done? So 5 can be divided into the 100. Do we agree? So it's 1 over what? 5 into 100 is 20 times. Yeah, better off that way. And if you know sides, you can still go beyond that and complicate your life a bit. Let me teach you some sides just on this one more step. So you have root of 120, right? 1 over 20. So basically, when you have a square root of 2 of a fraction, it's more like just distributing the roots to the numerator as well as the denominator. So you have the root of 1 over root of 20. So we know that 20 is basically 4 times what? Times 5. So multiplying things again is the same as splitting them with their roots. So which is just going to be 1 over 2 root of 5. Are we together? So that can be a solution. The most simplified form of the answer. Don't worry, we're not interested in this. This is another topic. You can end here, we can still mark your work. Okay, what other question did I give you? Okay, I think this is enough. People have catched up and we are on the same page now. So that has taken about 20 minutes of our time. We just do it. Okay. So now, we have talked about a complex number. We know of it from the different forms. Of course, a basic form where we are saying that, okay, our z is basically equal to a plus ib. Okay. So I want to look at we are looking at this as the rectangular form. So how do you get to express this one now in the form where you get to see your z is equal to r? Okay, so basically the way it is, it's cos theta then plus r sine. Okay, here it's basically it becomes two things, I r then sine theta. So that is the other form of a complex number. So that is called polar form. So they can give you a complex number in that form, then they ask you to express it in what? In polar form. That's what you have to be conversant with. Are we together? Okay, so how do we get to do that then? So basically I wanted to start with the basic idea of looking at it from the point of sketching. For people who watched the video that I made on complex numbers, I'm sure they are now conversant when it comes to the issue of sketching. So I made a point to say that this is your y-axis, right? We agree. That is your x-axis. So which part between the a and the b, or which part between the real part, so we call this part the real and that is the imaginary. So which one is represented by the y-axis there between the two? Okay, so it's basically the imaginary part that we get to plot along the y-axis. So let's have an example. So if you have 2 plus 4 high, how do you get to plot it? So go 2 to the right. So this is the x-axis, which is the real part. Then that is the imaginary part and the y. So 4i somewhere there. So that is the way we're going to plot our complex number. Okay, so now one concept that I want you guys to get is we have that is in polar form. In polar form you're going to write it this, so it's a triangle. Oh, it's in rectangular form, sorry. So this is what you have. So now basically this is going to take you back to vectors. If you draw that, you write your theta there. So what I'm trying to say, the point that I'm trying to make is, where is our a? We've said our a is what? Our a is the x-axis, right? Are we in agreement? So this is the x-axis. That is what? The y-axis. So we are saying that the a is representing the x, then the b is representing what? The y, which is the imaginary part of the complex number. So from there, that is where we have to get the point of the polar form. So what we're saying, in polar form, the complex number is going to be r cos theta plus I r sine what? Sine theta. So to just make it easier for you, we get to factorize the r there, so that we remain with cos theta plus I sine theta only. Okay. So what I want you to know is, if you look at this form that I've written down there, r is basically the absolute value. Are we together? Are we together? R is basically the absolute value, which we know is basically the root of a squared plus b squared. So if you know your a and your b, you're able to find the value of what? R there. So we found our value of r. So now it's a matter of finding the value of theta only. So if you go back to your vectors, what did you say about finding the angle theta there? How do you get to find it? You say this is tan inverse of what? B over a, right? Or y over a if you write. Y over x. Can we remember that concept? Okay, so that's basically what we're working. So I'm sure from what we've just talked about now, you're able to find now, right? You should be able to work it out. You're able to express it in that form, because if you're able to find the absolute value, you're able to find the angle, then you have written it in polar form already. Have we followed? Okay. Great. Let's try to look at an example then. So let's say for our complex number we have maybe let's put it this way. Okay, let's say 2 plus 4i. So how are we going to express this one in polar form? Of course, you should be able to memorize this. But it's not even a big deal, because you know that whenever you're dealing with vectors, you have the sine and the cosine part. Okay? So, what have we said? So we can first of all start by finding the area. What did I say? I said it's basically what? The absolute value, right? So it's going to be 2 squared plus what? Plus 4 squared. So what is your 2 squared? It's 4 plus 16, 20. So root of 20, right? So you've moved one step there, root of 20. It's just a matter of now finding theta. So angle theta, what are we trying to say? We're trying to say it's tan inverse of what? Of b over a. So 4 over 2. So 4 over 2 is the same as what? It's a 2. Is that even determinable? Does that exist? I read out. 63.4.
Yes.
Okay, so we have cos 63.4 plus I sine 63.4. Fine. It's that easy. Okay, it's very easy to work it out. Very simple. Are we together?
Sir,
Yes.
so is it possible to convert the polar form into the rectangular form?
Or the polar form to rectangular form. Is it possible?
Yes.
So basically, if you look at what we have here, do you think it would be possible? Because what you're trying to use is the concept of you using the theta and the r to get you back there. So, of course, what we say is the basic idea that we work with is when you're trying to change this to the polar form, right? Our a our a for the polar form is going to be r cos theta. Then our b is going to be what? It's ri or ir sine what? Sine theta. So if you have your angle theta there, you have your, what else do you have? You have your r there. I'm sure you'll be able to find your a, not so? So you find your a there. Then if you have your r again, your sine theta there, yeah, you should be able to find it. Very possible. Yeah, it's very possible. Yeah, because basically if you get your, try to get your calculator there, or yeah, basically yeah, it's very possible. It's possible.
It's possible.
But they usually get